When we first started talking about motion, we talked about displacement, which is how far something moves. Again, we're talking about motion in kinematics, but in this sense, we're talking about rotational motion. And so we're again talking about displacement. We're talking about how far, but it's now how far something is rotated. So again, the ideas here are not going to be any new. We're just going to do the same things, only now it's going to apply to rotating objects. So angular displacement is still how far, but it's how far something rotates. It's essentially an angle with a direction. And we still have, being a direction, you still have it as a vector. In this case, instead of being up positive and to the right positive, because that one makes sense with rotation, we think back to math class, when we did our unit circle, we went counterclockwise when doing our unit circle. So counterclockwise is going to be positive, and therefore clockwise is negative. And then we add 360 degrees. The most common unit that you're probably familiar with is degrees, and degrees was really just an arbitrary value. One time around was defined as 360. Now it's broken up into quarters to be 90, 180, and 270. So it's really just an arbitrary number that was come up with. The better option actually is the radian. That's something you may have come across before. With radians, we have pi over 2, and then we have pi, and then 3 pi over 2. And then when we get one time around, it's 2 pi radian. Well, where does that idea of this pi and the radians come from? It's not just an arbitrary value that was made up. It was actually something based on the measurements of the circle itself. And to understand that, we need to understand what the arc length is, which we abbreviate with the letter S. So arc length is compared to the radius. The radius is the distance from the center to the outside of the circle. The arc length is the outside length of the circle. Outside length of the circle. And so, here we have the arc length. And when that arc length is equal to the radius, so when the arc length equals the radius, then that is defined as an angle of 1 radian. It is based on an actual measurement of the circle itself. And so we can use that to formulate an equation. We can use this relationship now to formulate an equation. So the two of them divided by each other is equal to that angular displacement. So when they are equal, we get a value of 1. This does not work out with degrees. If I take the arc length and divide by the radius, I get a little less than 60 degrees. That's not going to work out mathematically. So this equation, which is usually written as arc length, is radius times angular displacement. We must be in radians in order to use this equation. That's what makes radians a more powerful unit that we can now use it to derive other values. So we must be in radians for that. What are these conversions between all of them? Well, if we look, we have from radians to degrees, there's pi radians for every 180 degrees. So if you want to convert, it's really no different. Let's say we have 90 degrees. I'll write out degrees a little bit. And it's no different than going from centimeters to inches. Well, there's pi radians for every 180 degrees. Degrees cancel out, and I get pi over 2 radians. It's okay to just have, not have the number pi in there. It's okay that the number of radians might be just 5. We can have 5 radians. You don't always have to have that value of pi in there. Another conversion here, if you want to go from degrees and revolutions, because revolutions or rotations is another unit. 1 revolution is the same thing as 360 degrees, one time around. And 1 revolution, one time around, is the same as 2 pi radians. So those are your 3 ways you can convert back and forth between the more common of the units. Now before ending here, I want to talk a little bit about this unit of radian one last time, and that is if we look at our equation for arc length equals radius times the angular displacement, we rearrange this to be arc length over radius equals angular displacement. We see that units of arc length is a meter. It's a length. Units of radius is also length. That's also a meter. And so, how does that equal a radian? Because it looks like on the left-hand side they cancel out. It turns out that a radian is actually a unitless value. There is no unit itself. But my guess is that since we are so used to writing a unit with an angle of degrees came before the radian. So since we are probably more used to writing a unit, we said, well, let's call it something, and since it's based off the measurement of the radius, let's call it a radian. That's just my guess. I don't know for sure. But it's actually a unitless value. And that's how we can get that the unit of the arc length is a meter, unit of radius is a meter, unit of angular displacement is a radian. Whenever something is written beside the radian, you don't say it. Whenever something's written beside the radian, you don't say it, you just leave it off, because it's actually a unitless value.